Welcome everyone to another Observability Clinic community episode 10. So these episodes are tips and tricks from our community, the people that actually use Dynatrace on a daily basis. Today's topic is about best practices on diagnostics. And I'm really happy that I actually have one of my colleagues, Josef, with me, who is going to show us how Dynatrace is internally using Dynatrace on a day-to-day basis. Josef, thank you so much for being here. Do you mind introducing yourself quickly, like what you do at Dynatrace?
Yes, thanks, Andy, also for the opportunity to be here. So I've been with Dynatrace for over 8 years now. I've been always in the same area, in engineering, in trace intelligence, we call it, which now also is going to be a little bit about what I want to show you today. And yeah, I'm a manager there for my engineering team. Yeah. Of course, as you say, community, so people who are using Dynatrace. I am from Dynatrace and we're using it ourselves, and that's what I want to show you
That's
right
perfect.
now.
Yeah, well then look, go right ahead, because I think the first slide that you have is actually an overview of what you're going to teach us today.
Yes, so what are you gonna learn today? Yeah, basically how you can profile your applications using Dynatrace. So this is one for the devs out there. We have so many tools in Dynatrace that are targeted for development. And yeah, some of them I want to show you today. So that the key ones, we at Dynatrace here, we are dealing with lots of data. We have to process tons of data. So it's extremely crucial for us to not waste have any bad code, have bad CPU usage and allocations. So these are the tools that I want to mainly focus on. It's about CPU. So there we have a few tools like continuous CPU profiler, method hotspots, of course, which many hopefully know, and also threat analysis. And on the other end, memory is extremely crucial to us, right? We are ingesting so much trace data, log data. So every part of Dynatrace really has to be very cautious about how to treat data. That's why I want to show you a really awesome tool that works for Java, the memory allocation analysis, which is like a key thing that you really only get with Dynatrace.
And Josef, this is really a great overview, and thank you also for putting all of these screenshots in, because I know these are screenshots from our internal tickets that we use when we have issues in production. Then we are looking at the Dynatrace data that we capture in production on Dynatrace. We create tickets for it, we give it back to the engineers, and then they collaborate on it. So thank you so much for really showing us that we as a large engineering organization are using Dynatrace on a day-to-day basis. And the listing here is obviously nice because, as you correctly said, a lot of people know us from distributed tracing, maybe from real user monitoring, but we have a lot of capabilities and features in the product that really help the engineers to optimize the application, to understand problems, whether it's in pre-prod or in production. And it's really great to get an overview. And now hearing from you on how we internally use it on a day-to-day basis. Thank you so much for that. It's a great preparation.
All right, yeah, cool. Then let's dive into it, I would say. But first, I've got one slide, which is also, I want to show you something. It's a little bit of a hidden gem in Dynatrace, as many things are, I would say. It's the API detection rules, which we call, which is something you should have a look at when you want to use our profiling capabilities in Dynatrace, because it really enhances your experience, I would say. So yeah, where do you find that? I can show you that in a minute also really quick. So under settings, server-side service monitoring, API detection rules. And what you can do there is you define yourself, you know best what your application is really about. And you can slice the application, different parts where maybe different teams are responsible for that, or it's just architecturally different parts. And you would like to split all your future investigations maybe by that. So what you do is basically you define there which parts of your application are what. You can give it some nice colors also that enhances your experience later on. And also you can define what is a third-party library, so something where you can't really change like the code inside, or what is your code, so that this allows Dynatrace to bubble up the problems to your code basically. because then you can decide, okay, do I want to like switch out the third-party library or not? But yeah, but you always know where it impacts you, basically. Yeah. And yeah, as I said, it really enhances everything in profiling, also in tracing as well. You can see the colors and everything there as well. And yeah, you will get grouped, like the data grouped by APIs in some screens. You will see the colors. You can filter for these APIs. And basically, it lets you also focus on your part of an application. Sometimes we're dealing with very big applications and it's hard to spot really, like everyone wants to look at something different, right? So yeah, the APIs help you there.
And I think,
yeah, just quickly.
Yeah, I was just saying, as you're going over to the settings, please do so. I think what's also good to know is by default, Dynatrace tries to detect obviously your APIs automatically, right? I mean your layers, like which classes, which packages belong together. We know a lot of the default like very common packages, and so we give them already some, as you can see, the built-in rules. That's perfect. Yeah, thank you for that.
Yeah, so we have tons of built-in rules, which you can, of course, override if it's not fitting for you. And yeah, for today's demo, you can see I already added some of my own APIs for my application, which I want to show you today. And yeah, some more stuff. And it's really easy to configure. You just put in your color and yeah, basically you tell it by really using, for example, the class name or whatever, or your package name, what is what, and yeah, that's basically all it is. And even one more thing, even like when we write metrics about allocation data or CPU data, you can sometimes find also these APIs as dimensions on the metrics. So that's also really cool.
And the good news here is these are all settings. That means I assume you can also configure these settings via APIs. That means you can fully automate it as well. You don't need to manually define this in Dynatrace, but you can do this through configuration as code, through API calls, kind of including it in your development process.
It's absolutely crucial for us. Also, we have many environments and you don't want to like always sync everything manually, right, to every environment. So that was also really important for us. Yeah. Okay, then yeah, I'll quickly go back into my slides. So yeah, the first part, I think most importantly, I think is about CPU. So we have, yeah, whenever there is a problem, usually you can see things via the CPU. And yeah, there I want to show you 3 awesome tools that Dynatrace offers. So the continuous CPU profiler, the method hotspots and thread analysis. And yeah, CPU profiling is there for all of our technologies that OneAgent supports. Same for method hotspots. And thread analysis is something that we currently just have for Java and Node.js. Yeah. But yeah, don't want to bore you with any slides. I want to jump right into the demo. All right. So yeah, you know, I'm an engineer, so I also had to do an engineering demo, which showcases all that stuff. So I have here a Dynatrace profiling demo, and I have demo A, B, C, D. And you saw that before in the API, so I configured that the same. And yeah, when we jump into the code, basically what I have is I have 2 kinds of data. I have users. So you can see it's not really a database, but just some static users. And you could see it as kind of like a game show. Every user has points. And what they have to do is they have to do jobs to earn points. So I also have a job database. And this is basically where then I get my CPU usage from. I want my threads to work on those jobs, do some stuff so I can observe it in Dynatrace. And yeah, you can also see, like, I'm going to show you thread analysis later on. That's why I needed some kind of like people working together. It's also always about threading, right? So I have always 2 users that work on a job. And each job is done by 1 thread. So we do all threads in parallel, all jobs in parallel. And then when they are all done, we will see it in the UI, like the points total of every person. Yeah. I can, let's just click on demo A, and you can see we're now waiting until the job's finished. So they're doing some work. I can actually show you why it's taking so long. I mean, it's an easy thing to spot now in my code, right? It's just a few lines of code. But yeah, so what we can see for all of my demos is I have this worker which does a job. It gets the 2 users from the database, then it calculates the reward. And in my case, the calculation is just calculating the Fibonacci number, so that we can observe some CPU usage there, hopefully. Yeah. And yeah, once we're done, we're locking our users so that we don't have any problems with that, and we give them the reward. Yeah. And yeah, in my logs, I can already see that some jobs already finished. All right, some additionals are still working. Let me check. All right, I think now maybe they're still doing stuff. So we want to really show some CPU here.
But it's great. Josef said you actually that, you mentioned this earlier, as we are building also features internally, we also want to always make sure we have ways to demo it. I mean, fortunately, we can use the product in general on Dynatrace, but it's also great that you built this demo app just to really showcase all of the different things that we've observed over the years that can potentially go wrong, like the different problem patterns as it comes to CPU hotspots, any type of thread congestion, or memory challenges. So thanks for also building a demo that makes it then easy for you to demo the stuff that we have in Dynatrace.
Yes, so I'll just stop this one and let's just use Dynatrace and see what's up. I think this demo should actually finish, but now that I'm using Zoom, probably my CPU
Zoom is eating a lot of CPU.
Yeah.
But that's real world scenario, right? Because in the real production environment, you might not be the only CPU consumer, and all of a sudden you're constrained by also other CPU that is eating your CPU away. So it's all good.
Yeah, and maybe something I forgot. So how do you actually get to all of this data that I'll show you? I just installed the one agent and let it run locally on my machine. That's something we at Dynatrace do, like we all do that. So all engineers, they just install the one agent locally, and basically we are using our own product, even in the dev stage. So not just in production, but even in dev stage. So that's also something really cool. Yeah, so of course, we're talking about profiling. So we have our profiling and optimization section. And our big entry point for CPU and for memory is the continuous CPU profiler. And you can see I already tested, I did a quick demo like an hour ago. But let's now focus maybe on the last 10 minutes. And here we can see, the spike here when I started my demo. On the one hand, it's my IntelliJ IDEA that is spiking, but also my demo application. And basically I want to know what's up with the demo application. So I go to Method Hotspots. This is this this analysis icon here. Yeah, and let's just see what's happening there. All right, so I think I still have some job from work demo C running. This is not good. Maybe I should have restarted the app.
That's okay. We can always
Cut noch machen. Yes. Oh.
We can also
I'll restart. Maybe we can do this quick section once more.
Sure.
What do you think?
We can also, this is also the beauty of recording those, but also doing them live. I want to keep them as it is because this is just what happens in real life, and so people also see a little bit. So the reason what you said, you had this application obviously running for a while, and it was still most likely
and I had
executing.
yeah, the worker C is doing some threading stuff, and I did not terminate that correctly. So yeah, now I restarted everything. And hopefully now when I do demo A, it should finish sooner. It shouldn't block any threads. You can check that. So I can see my jobs are starting and finishing. And yeah, now I can see the result that I wanted to have before. Yeah.
Okay, cool.
I mean, it's interesting. I can see here already demo 3, but yeah. Yeah, so maybe now let's go here now again to the last 10 minutes. As you know, we need like a little bit of time for Dynatrace, for the one agent to send in the data. It's not like every second we send in data. Like for CPU data, it can be like every minute we send like we collect this data that we collect every second. Yeah, so let's maybe try again, last 5 minutes. And yeah, here we can see I shut down the old threads and I started up the new ones. And before we had a locking problem, which is now going over to like a network versus code execution. Like, so yeah. And basically the easiest way in method hotspots, what do? You just click on the hotspots button and let Dynatrace tell you what's going on. And yeah, I still want to get rid of this here, so I'll do it once more, like maybe last 5 minutes. So yeah, let's see. I want to go to the code execution because the locking is still from the problem before that I want to show later on. And I can filter for now just a CPU code execution problem. And I can basically already now know what is my code doing. And I can see like most of my CPU is working on in this method calculate reward. That is not really a surprise to anyone because this is basically where I do this Fibonacci number calculation. Yeah. And yeah, at Dynatrace, you know, we would see this hotspot and we would think, could we optimize this? Yeah. And basically, I now in my demo B, I wanted to try something out to optimize this code. So in demo A, I had this as a recursive function. And of course, you can always write it also iteratively, right? And yeah, I just, you know, let's figure out what's faster. Yeah, so basically, I'll just try it out here with trying out the demo B. Let's let it run a little. We can also see now the jobs for demo B are now starting and already some are finishing. So it seems like maybe it's even faster now. Yeah, let's check. Let's let it run a little bit, but yeah, it seems a little suspicious that it's running again so long.
Yeah. Hey, Josef, so, I got one question now for you. From a pure development perspective, right? You're using IntelliJ. Others may use Visual Studio Code. Why would you use Dynatrace for this? Why not just use the native tools that are in the development in the IDE?
So I think, yeah, in development, yeah, you can use many tools, right? But what do you use in production? There, I cannot just say, okay, now there is a problem, please, like start like a flight recorder. Also, flight recorder is like would be really bad probably on CPU, right? And yeah, when in production, of course, I use Dynatrace. And if I want to also see the same problem I see in Dynatrace, but locally, then it's like a no-brainer to also use the same tool here in dev. And to be honest, it's really easy because when I start my laptop, I don't have to say, okay, please Dynatrace also start up. The one agent just starts. And if I have a problem, I can be sure that the one agent picked it up. I don't have to run in debug mode or whatever. It's Dynatrace is always in there. So yeah.
I think that's it.
I think the main advantage.
Exactly. That's the great point, right? As you said, if you install the one agent on all of your development workstations, wherever they run physically, if they're virtual, install the one agent, and by default, you get everything collected, all the data, and all the data gets sent to a central Dynatrace server that we have. We call this Dynatrace tenant and Dynatrace environment. And so that means you also don't need to worry about where to store this data. Everything is taken care of. And that's great, right? And so whether it's production, whether it's pre-prod, whether it's development, single tool. Now it seems your demo app is mocking up a little bit, huh?
No, this is actually, I think, part of what I wanted to say. I wanted to show. So, you know, as in development, everyone knows it. You change some code, you don't have enough tests, right? Something, and you get a problem. And this is exactly what in demo B now, the problem is. If you just look at the code here now, like you can investigate a lot, but you probably will not find, it would be very hard to find the problem. But maybe Dynatrace can guide you there. And this is what we can check out now. So let's again see what's happening in the last 5 minutes. We can now see like Dynatrace is detecting the worker demo B calculate reward as the top hotspot here. Mm-hmm. And yeah, we can see also like 30% of the CPU is just doing this method here. And method hotspots alone can guide you where the problem is, but maybe cannot really solve it for you. And this is where I did some magic also because it's about workers. What we can try is, and the second tool I want to show you today, it's about thread analysis. So these two are very tightly coupled. We can quickly jump over to thread analysis directly from method hotspots. Mm-hmm. And what's the cool thing about my demo is, and hopefully you can make your applications the way too, right, is that you can basically call your threads what makes sense, right? Mm-hmm. And for worker demo B, all the jobs, the workers that are doing those jobs, I gave them this name plus I gave them the job ID as the thread name, and this is what Dynatrace then detects and can basically split up all the CPU usage and everything what has been done by thread ID. Mm-hmm. And yeah, I can see here that there is this thread group that Dynatrace detects, which is doing the most work. I can drill into it, and then it tells me, okay, in the last basically minutes, what I mostly saw, the other jobs, they were finished so fast that they were drowned out basically by this job 5 that is basically consuming all the CPU. And this is why this job 5 just, as you can see, mm-hmm. It's running still till the end. It's not going down. And yeah, what we can then investigate what is job 5 doing, right? We could look into some database to see what was the data that was job 5 executing. And yeah, it's really easy in my case because I have the database in the code. Mm-hmm. And what I can see is here's the job 5. I can see Mark and Chris should do it together. And yeah, I can see there is a problem. So the reward is negative, or maybe it's not a problem, but it's unusual. The others finished, had a positive reward. This one did not finish, had a negative reward. So together with now what we saw in method hotspots, that the problem was in calculate reward, right? It was stuck. Mm-hmm. We can investigate this with the added knowledge from Dynatrace now. Mm-hmm. And we can see that I messed up the if statement here. Mm-hmm. I just assumed there's only positive rewards. Mm-hmm.
And therefore basically get into an endless loop.
There is a negative reward. Yes. And yeah, so next iteration, you get a bug, you fix it. I fixed it in worker demo 3, worker demo C. You can see I just changed this here, and yeah, we can check if my fix worked basically. So let's just run demo C.
The good news here, Josef, is that this reminds me of my days when I was still actively developing. It felt like trial and error. And seeing you, it also feels a little bit the way this is still software engineering, right? You're doing a lot of experimentations actually to make sure you're getting the right results and that you're also obviously optimizing. Because I want to highlight this because a lot of people that might watch this, they feel like new to this, or they feel like, okay, this is how it works. This is how you actually software development process. It's a lot of experimenting, right? And it's great that we have tools that give us immediate feedback about the behavior of our apps.
Yeah, I think just like with engineering, it's sometimes hard to look into things, right? So there is no, like when you're building a house, you can directly see where the problem is, right? But with programs, it's hard. So it's really good to have something here. Yeah, so as we can see, and broken, you get your next ticket. Yeah, let's again look into Dynatrace, because I basically thought I just changed this. Maybe I did some refactoring somewhere along the line, or maybe somebody else changed my code in between. It's always hard to investigate. And yeah, so I'm going back to the method hotspots to see where the CPU is consumed. Yeah, I'm removing my thread group B filter again here. And yeah, let's just check out easy again the hotspots. I'll have to do last 5 minutes again. So let's check out what's going on. And yeah, we can see now a different color. This was the color we saw before as well with the locking. So there is, this looks very much not like a CPU problem, as you can see, but it's a problem with some locked threads. Yeah. And it actually, again, tells me where the locking is happening. So method hotspots tells me, all right, somewhere in worker demo C, do job, we can see that there are threads stuck in the state, in the locked state. Yeah. And yeah, now it would be nice to know which threads are stuck, right, in the locked state. So yeah, why not use a thread analysis again to check this out? And here I can filter again for just the locking code that we can see here. So yeah, it's the demo C, of course. And really cool thing is now it actually tells me which jobs are stuck. Yeah. So this is something you really don't get. I mean, what we could have checked is like our logs. We could check which thread started, which didn't finish. But it's really hard, I think, in logs to investigate such a problem. But when you know what you're looking for with profiling, it's a lot easier. And Dynatrace really shows you easily what the problem is.
And to make,
yeah,
and
so
to
we
make
know
this,
job
to make
4 and
this,
job 1.
yeah, to make this even, I think one thing I want to reiterate here, because you said this earlier, all of this happens out of the box. However, as a good coding practice, you should give your thread proper names, right? Like you had it with your thread groups and your individual thread names. This is just the best practice anyway. I assume every developer is following, but maybe there's developers that were not aware of this, that you can even do this. The better you prepare your app for diagnostics, the easier the diagnostic steps will be.
All right, so it's still going on. The locking is still going on. Yeah, we know now it's job 4 and job 1, and due to method hotspots, we know even where to look at the two job directly. So yeah, let's check basically our code in demo 3. So we know it was demo C, do job, and somewhere here the locking happens. And yeah, I mean, if you're like if you're used to Java code, to threading, synchronizing, then you can easily spot here the problem. What we do is now we lock user 1. We also lock user 2, and then we release them. But this, of course, could, if you have these nested locks, which in this case, I did not have them here because, but somebody messed up the code and not easy to spot, I would say. And if we now look at the jobs, so here we said job 4 and job 1 caused this problem. If we look at job 1, we see there is Joe and Sally working on it together. And in job 4, we have Sally and Joe. So basically, the first thread is locking Joe. Meanwhile, the thread 4 is locking Sally. And then when thread 1 wants to lock Sally, it has to wait. And when the other thread wants to lock Joe, it also has to wait. So they basically reproduce the deadlock. So the easy fix would be here to just go back to like normal locking. So like that. And that would solve the problem. I think, yeah, you can trust me on that. Not sure if don't want to restart now again. Yeah, so that's basically the power of method hotspots, thread analysis in combination. I think two really cool tools, and I hope I can inspire more people to use them now.
Yeah.
With that,
And maybe Josef, before you go on, can you tell people again how you got to the profiling tools in Dynatrace? I know you brought it up quickly in the beginning, but just a reminder.
Yeah, so as you know, we released a new app shell, so things are easy to look into there. So just searching for it, for the profiling and optimization app, or with the old, as what maybe you're used to, they're also on the sidebar, you can see the profiling and optimization app. You basically get to this page, and yeah, but your main entry point currently is then the CPU profiler, where you see all your process groups listed based on impact. You can filter here very nicely also for different technologies or names or even tags when maybe your team has a certain tag. And then on the side here, you can see all those tools that I'm mentioning today. So it's really easy to jump into from here.
Cool, thank you.
Yeah, one tool. So what I also said is memory problems. So that's the other side of things. Sometimes it's not the CPU, but maybe it's like the memory that is overflowing. And I think here Dynatrace also shines a lot with our memory allocation analysis. So so this is just supported for Java because we need some special APIs that are provided by the JVM. And it's provided by JVM from a version 11 on plus, with some, all the major ones supported, but you can see it has to support low overhead heap profiling. And yeah, you need to enable this continuous memory profiling agent feature, which, for new, like if you're more of a recent customer, then this is enabled by default anyways. But yeah, as we're very stable with that. And yeah, let's just jump right into. I think this is also a really cool case because you never know what Java is doing with your allocations, right? It's like the garbage collector is there, and just you hope for the best. But with Dynatrace, you can basically get some extra info what is actually happening. So that's really cool. So the demo D is a bit of a different demo now. It showcases our allocations. You can see the results are a bit bigger. I'll just let it run a few times so we can actually, Dynatrace can see a bit more data, not just a few kilobytes or so. And meanwhile, I can show you what I'm doing. So for each job, I don't care about the points here anymore. I just want to do a simple demo that I always wondered about. You always hear about when you want to build a string about lots of different components, like you're looping over data and you're aggregating data. What you could do is you could just simply create your string, and you always use the string concatenation to just add to your string. And as a new developer, like that's what you're taught, like the first thing, how to manipulate the string. You just add to it with plus. And then I return that string, and I do the same, but also there are different methods as well. When you look into online a bit, people tell you, use a string builder instead because it's more performant. But how do you figure out what is more performant? You can use Dynatrace basically. So I'm doing the exact same thing, but here I'm not using the string concatenation, but I'm just appending to this string builder. And in the end, I tell string builder, please give me the whole string. I do that, as you can see, 1,000 times, and the same. So 1,000 times 1,000 times for each string. And we can see now in memory profiling, hopefully, the results of that. So memory profiling, similar entry point. You can do here via the CPU profiler, where you have your process groups. but also directly on the process group page, you can also see memory profiling easily. Yeah, so memory profiling. Let's also go to last few minutes. Maybe I have to click a few more times. Sometimes takes a while to get data.
Maybe your app is too efficient and too fast. Oh, here we go.
Yeah, so here we can see data there. We can see over the last, so this app basically that I was running, where we allocated 140 megabytes in this one process during the runtime of my app. Basically, I'm not doing very much with it. And yeah, we can see also what's really cool is how often the garbage collector did, like a garbage collection here. And yeah, you can see when I started, like at first I didn't do much, right? I just did a Fibonacci, and I never really held onto any allocations for long. And yeah, here you can see things intensified. So with the demo D, basically. And yeah, we have some different kind of visualizations, which I think really cool. So on the one hand, we have the flame graph, which tells you, like, shows you visually where are the areas where the most memory is consumed. We can see for my app, I'm using Spring Boot. So there's lots of Spring stuff that I'm not really so into it. And then there is, let's see, yeah, I have my API again here. I'll just use demo D because I'm not interested in the Spring stuff. I'm just interested in my demo that I want to show. And yeah, so what we can see here now is my demo application, my worker, and then my demo D. And basically here I can see now the data is here. It's actually 8.7 gigabytes that we allocated in just with demo D, right? And then we can see it's hardly noticeable here, but like I would say 90% of that data is done in the string concatenation case. Meanwhile, we have this tiny little thing here, which is the string builder. It's just 100 megabytes versus 8.6 gigabytes. And yeah, then we can also see what is going on directly below that. Yeah, we can see that Java is doing some things, yeah, that I don't really know about, but it's also using internally something like called a string concat help on new array. And on the other side, what when you're using a string builder, what is happening is you can see the string builder append here. So let's maybe filter for that part only. You can see, yeah, basically not a lot of stuff is happening here. Yeah, it's also internally using some arrays, but yeah, you can see in the comparison. Let's go back. Maybe this part here is a little better to show then. Dynatrace basically also looks at this flame graph, and it then gives you the hotspots again. And yeah, we can see for the demo D there, we can see two things that are creating strings, or in this case, arrays mostly. It's again, you know, the string concatenation with the 8.6 gigabytes versus the case just 100 megabytes on the string builder. So that you can see it has huge impact what you're doing when you don't know what to do.
And it's fascinating because I remember when I went to high school and we went through the exercise of building strings, and we had the same thing, right? Where you are just doing a loop and then using the plus operator, and how that internally, what Java does with it, you know, I have no clue. But we always knew that the string builder is the preferred option, we were told. But seeing this here with facts is amazing on how much memory is actually wasted if you're doing inefficient concatenations of strings. This is 1 megabyte versus 100 megabyte versus 8.6 gigabytes. It's just the magnitude of difference that is unbelievable if you don't know it.
Yeah. And so what we do at Dynatrace is basically for our whole Dynatrace applications that we have. We compare version by version. We check, the top hotspots, and then we observe which things grow a lot, which are like, where is a growth that is not explainable by a new feature or so. And then we question again the code. And it's really up to us then to also say, hey, we cannot roll out the new Dynatrace version because we don't know why this is happening. Why is there so much more allocations here that is impacting us as a SaaS company, right? But also our managed customers. They also all of a sudden would need maybe bigger machines to run Dynatrace. So yeah, this is really important that we have a look at our allocations.
And the interesting thing, and this is just a reminder again, what we said multiple times, this works all out of the box. The only thing you need is install in one agent on either environment, production, pre-prod, development environment. Dynatrace will automatically collect this data. You mentioned also for people that have had Dynatrace for a longer time, maybe that continuous memory profiling has not been activated because with a new version that we roll out, we don't typically change default settings. So you may need to look into this in the monitoring settings. But if you are a more recent customer user of Dynatrace, this setting will most likely be on. And with this, you get all of this data. And Josef, just another question on automation. I assume there's also stuff where this data can be automatically extracted through an API, like we are exposing some of this data through APIs, so we can build this into your CI/CD process in your pipelines.
So far, what we have is we create, so the metrics you can see here in the chart, rewrite them. So you can basically compare maybe the metrics. You can see this also in the documentation later on that I linked. And as a dimension, we also put the API here once more again on these metrics. So you can compare also different sections of your application grow more or less. That's also, But as you know, now with Grail, we are, as a company, we try to open up more our data, right? So this is, so far we don't have sadly the profiling data in there, but this is of course just a logical next step, right? To make this available. Would also love this as a Dynatrace user myself to pull out this data easily, right? So this is certainly also on the plan.
Well, it's good that you are in the pole position of actually implementing these things in Dynatrace. So that's why I think we are so fortunate that we are kind of we call it customer zero. We're the first customer user of Dynatrace capabilities because we are using Dynatrace itself on a day-to-day basis. And then if we see something where that can be improved or that is missing, we are obviously in the pole position to make sure that this gets into the product. This is really fascinating. And what for me is interesting, we typically talk about distributed tracing, right? Which is very important, right? Getting end-to-end traces, whether it's through the one agent, whether it's through open telemetry. But you are showing us here, or what you've shown us here, are diagnostic options that are in Dynatrace that are actually outside of the distributed tracing world. Now they all interconnect, obviously, because if you do distributed tracing as well, then the data gets intertwined. But with CPU, thread, and memory profiling, you get such a great opportunity to identify your hotspots and then optimize your applications, whether it's in production or whether it's in pre-prod or in development. Josef, anything else on the demo? I think you showed 4 apps. I think we are. Do we have anything else to show?
No, on the demo, I just have one last slide that I want to show you. So, let me skip through. So it's basically just links to everything that I showed you. So of course we have documentation for all of that. And I know you also added a link yourself, right?
Exactly, yeah. By the way, these links, I will add them to the description of this video. So if you watch this on YouTube, you see it on the bottom. If you watch this on Dynatrace University, we also upload the slides, by the way. But yeah, the last one here, I think about 2 years ago, 3 years ago, one of our colleagues, Sergio, he created a series of tutorials. It's called Why Devs Love Dynatrace. and going through all the different diagnostic options, covering some of the stuff that you showed today, but also covering your distributed traces, your pure paths, how to integrate this with your CI/CD. So check this out as well. And remember, the links will be in the description. Really good. Hey, Josef, this was really awesome, educational. I didn't know some of the things, even though I've used the product for so many years. It's always great to learn something new, and especially it's our users that are watching this tips and tricks session to hopefully you've inspired them and you will make their day-to-day life easier as they're finding and hopefully also fixing any problems they have in their apps. Thank you so much.
Yes, it was a pleasure to me as well. So yeah, I can just say try it out. And yeah, if you have any feedback for us, we're listening in on the community channels, right? There is the idea section there as well. So yeah, hit us up with some feedback, and yeah, would love to hear.
That's a good point. I will also add the link to the community, because that's a great place to not only ask questions, but also, as you said, give feedback and come up with ideas. Awesome. All right, with this, I want to say goodbye. Danke, Josef.
Thanks. Goodbye.
Bye.